All right, welcome back to our unit on bonding. Today's topic is Lewis dot structures. Okay, lesson 2 of 3, your objectives are as follows. To understand what valence electrons are and how they are involved in the bonding process. Okay, to learn what the octet rule is and how we apply it. To learn how to draw dot symbols for individual atoms or elements. To learn how to draw Lewis dot structures for molecules. For your Quickwrite. Do you think it is the electrons farther from the nucleus or closer to the nucleus that are involved in the bonding process between two atoms? If you had to draw a molecule, what kinds of shapes might you use? When atoms share electrons, do you think they become more or less stable? And finally here, let's say you're playing blackout bingo. To win, describe how your bingo card should look. Okay, go ahead and pause this while you do Quickwrite. I'm going to move on. All right, so valence electrons. Valence electrons are the electrons contained in the outermost shell of an atom. These electrons are involved in the bonding process between atoms. Okay, you can use your periodic table to determine how many valence or outer electrons each element has. Okay, for example, hydrogen has just one valence electron in its outer shell here, and your periodic table here, okay, with that 1A tells you that it has one electron. Well, carbon and all group 14 elements have 4 electrons, valence electrons, 1, 2, 3, and 4 valence electrons in its outer shell. Okay, and nitrogen, okay, and all group 15 elements have 1, 2, 3, 4, 5 valence electrons in its outer shell. Okay, so nitrogen, phosphorus, and all group 15 elements. And oxygen and all group 16 elements have, you may have guessed by now, 6. 1, 2, 3, 4, 5, and 6 valence electrons in its outer shell. Okay, and finally here, okay, fluorine and all group 17 elements, fluorine, chlorine, bromine, have 7. 1, 2, 3, 4, 5, 6, and 7 valence electrons in its outer shell. Okay, so those are the valence electrons. It is important to realize that elements in the same group, in the vertical columns, all contain the same amount of valence electrons in their outer shells. Okay, so for your notes, what are valence electrons? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. Okay, I'm going to move on. All right, so electron dot symbols. Electron dot symbols are representations of an atom that shows how the valence electrons are arranged. Okay, the electron dot symbol for hydrogen is represented by an H, okay, the atomic symbol here, with 1 dot or valence electron around it. Okay, so because hydrogen has only one electron in its outer shell, we put, okay, just 1 electron next to it. Okay, but carbon, if you remember, has 4 valence electrons. Okay, so the electron dot symbol for carbon is represented by a C surrounded by 4 dots or valence electrons. Okay, and then the electron dot symbol for chlorine is represented by Cl, okay, surrounded by 7 dots or valence electrons. Okay, it's important to realize that electrons are typically expressed or written as pairs here. So we write them as pairs, 1, 2, 1, 2. Okay, so 2 pairs, 4 electrons total. Okay, and it is also important to understand that electron dot symbols show only the valence electrons, and these are the electrons involved in the bonding process with other atoms in their outer shell. All right, so for your notes, what are electron dot symbols? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so practice. Write the dot symbols for hydrogen, sulfur, and bromine. Okay, when you're ready to check your work, hit play. All right, let's see how you did. Okay, so for hydrogen, only one electron next to the element. Okay, and for sulfur, well, it's under oxygen, which has 6 valence electrons. So 2, 4, 6 electrons. Okay, and then bromine. So 2, 4, 6, and 7 dots or electrons around it. All right, so hopefully you got those right. So the octet rule. Remember, chlorine contains 7 valence electrons in its outer valence shell. Recall that the dot symbol for chlorine is written as such. Okay, it's got 2, 4, 6, 7 electrons around it. Okay, just like bromine does, and so does fluorine. So atoms such as chlorine, though, they aren't happy with only 7 valence electrons. Okay. On the other hand, atoms such as argon, which is right next to chlorine, are very happy. Their outer shells are full. Okay? So in fact, all noble gases such as argon and neon have completely full outer shells, and they're happy. Okay? Because their outer shells are full with 8 electrons. Chlorine would like 1 more electron, so its outer shell is full. Total of 8. This way it is happy like argon. Okay, so nonmetals such as chlorine want to be like their nearest noble gas. Okay, neon, argon, krypton, xenon, and so forth. In this case, the nearest noble gas to chlorine is argon. Okay, and it wants an extra electron, so it will be happy here. Okay, so when atoms like chlorine covalently bond, they try to fill their outermost shell. Okay. Remember, chlorine gas, Cl2, is a naturally occurring diatomic molecule. When chlorine bonds with another chlorine atom, it bonds in a way so that its outer shell is full, and both atoms contain 8 electrons. So notice here, Cl2 bonds in a way so that its outer shell has 8 electrons, and it's happy. It meets the octet rule. Okay, or the octet rule is satisfied. So in other words, like I said, when they bond, they satisfy the octet rule. So the octet rule is a simple chemical rule of thumb that states that atoms tend to combine and bond in such a way that they each have 8 electrons in their valence shells, giving them the same electron arrangement as a noble gas. Okay, so notice they bonded in a way so that they now have 8 electrons and they're happy. They meet the octet rule. Okay, so for your notes, what is the octet rule? Question on the left-hand side, answer goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. Okay, so Lewis dot structures. To better understand the bonding process between atoms, chemists construct visual diagrams or representations of molecules to reveal how valence electrons interact or bond with each other. Okay, we call these visual symbols of molecules Lewis dot structures. Okay, well, chlorine gas was a simple example that we saw earlier here. Okay, so there's a simple Lewis dot structure. Okay, but water, H2O, is another example. We can draw the Lewis dot structure for water. Okay, oxygen has 6 valence electrons. Hydrogen has 1, so they bond in a way so that their shells are full. Remember, hydrogen can only have 2. So hydrogen has 8, okay, or excuse me, oxygen has 8 and hydrogen has the 2 it needs to fill its shells. So there's a Lewis structure for water. Okay, so Lewis structures are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Okay, the lone pairs just mean like these 2 around oxygen that are lone. They're not bonded to hydrogen. All right, so for your notes, what are Lewis dot structures? Question on the left-hand side, answer on the right-hand side. Okay, go ahead and write this. Okay, I'm going to move on here. All right, so steps for constructing Lewis structures. When constructing Lewis structures, there are several steps we must follow. Okay, so for example, let's follow each step to draw the Lewis structure for SO3, sulfur trioxide. So step 1, determine the total amount of valence electrons for the molecule. Okay, well, sulfur has 6 valence electrons, 1 times 6 for 1 atom. Okay, oxygen, there's 3 atoms, so 3 times 6 is 18. Total is 24. So we have to have a total of 24 valence electrons. Step 2, determine the center atom. The center atom is the least electronegative atom, or the atom that occurs least amount in the chemical formula. Okay, in this case, it's sulfur. Step 3, place the remaining atoms around the center atom. So let's put those 3 oxygen around. Okay. Step 4, let's put some bonding pairs of electrons between the sulfur atoms and the oxygen atom. Okay, because they got a bond. Step 5, satisfy the octet rule. Let's go ahead and place the remaining electrons around the outer atoms first, then the center atom last, if need be. Okay, so there's step 5. So we have total 24 valence electrons. Okay, are we done? Does each atom contain 8 electrons around it? Well, doesn't look like it. Okay, oxygen has 8, this oxygen has 8, and this oxygen has 8, but sulfur here in the middle only has 2, 4, 6. So we need to move on to step 6 to satisfy the octet rule for sulfur. Okay, so step 6, let's move some electron pairs to create double bonds, which is 2 pairs of electrons, or a triple bond even, if need be, which has 3 pairs between atoms. Okay, so let's shuffle some electrons around here, create a double bond there. Okay, and okay, each line represents a pair of electrons here, and there you have it. Let's double check here. So which brings us to step 7. Okay, so count electrons around each atom to make sure the octet rule is satisfied for every atom. 8 for nonmetals, 2 for hydrogen. Okay, so sulfur has 8, 2, 4, 6, 8, and each oxygen has 8, it looks like. And there must be a total of 24 valence electrons here. Okay, no more or nor less. All right, so which we have 3 times 8, 24. All right. So for your notes, what are the steps for constructing Lewis structures? Go ahead and pause this while you write. I'm going to move on. All right, so practice here. Draw the Lewis dot structure for N2 and draw the Lewis dot structure for CO2. Okay, go ahead and pause this while you work on these. When you're ready to check your work, hit play. All right, let's see how you did. Okay, step 1. Determine the total amount of valence electrons for the molecule. So for N2, we have 2 times 5, which is 10 total. Okay. Step 2. Well, we can skip this step because we have only 2 atoms. Okay, we don't need to determine the center atom in this case. Okay. Step 3, let's just add in our other nitrogen atom here. Okay, and step 4. Place bonding pairs of electrons between them because we know they're going to bond. Okay, the question is it a single, double, or triple bond? Well, we can already place 2 electrons there because we know they're going to bond. Okay, step 5. Satisfy the octet rule by placing the remaining electrons around the outer atoms first, then the center atom last. So we've used up 2, we have 8 more left. Okay, so we can start placing those 8 electrons, okay, around the outer atoms first. Okay, and there we go. We've used up our 10 electrons. All right, so is the octet rule satisfied? Well, it doesn't look like it. This nitrogen has 2, 4, 6. Remember, we need 8, and there's not 8. And this nitrogen has 2, 4, 6. Okay, there's not 8 there. So we need to move on to step 6. Okay, move electron pairs to create double bonds or triple bonds between atoms. So we got to move some electrons around here. Okay, let's move those, create a triple bond. Okay, and now, okay, let's move on to step 7. Count the electrons around each atom to make sure the octet rule is satisfied. Remember, there's 8 for nonmetals, so 2, 4, 6, 8. Okay, this nitrogen looks good. Let's check the other one. 2, 4, 6, 8. There we go. Okay, we're good. That is the correct Lewis structure for N2. All right, let's try carbon dioxide here. Okay, step 1, determine the total amount of valence electrons for the molecule. Okay, so we have a total of 16. Step 2, determine the center atom. It's the atom that is the least electronegative or the atom that occurs the least amount in the chemical formula, okay, which is carbon. All right. All right, step 3, let's add in our other 2 oxygen atoms here. Okay, step 4, place bonding pairs of electrons between the atoms. So we can go ahead and throw a bonding pair of electrons in there first, okay, because we know they're going to bond. All right, step 5. Okay, we got to satisfy the octet rule now by using up our remaining electrons around the outer atoms first. So we've used up 4, so we need to start adding 12 electrons to the outer atoms. Okay, so 2, 4, 6, 8, 10, 12. Okay, so we're good there. We've used up all 16. Now let's see if we've satisfied the octet rule here. Oxygen has 8, we're good there. This oxygen has 8, we're good here, but this carbon only has 4. So we need to move on to step 6 and move electron pairs to create double bonds. Okay, so let's shuffle some electron pairs around here and let's move these, okay, to create some double bonds there. Now let's see if the octet rule is fulfilled. So step 7, carbon has 8, oxygen has 8, and this oxygen has 8. So we're good. And this is the correct Lewis dot structure for CO2. Okay. All right, so resonance. When creating the Lewis structure for CO2, you may have come up with a different structure, such as the one seen below, which has a triple bond along with a single bond. Okay, so we have a triple bond along with a single bond here. Okay, both Lewis structures are correct here. Both of these are correct, which leads us to a new term called resonance. Okay, a molecule shows resonance when more than one Lewis structure can be drawn for the same molecule. Okay, so in the case of CO2, 2 structures can be drawn, which this is an example of resonance. Okay, so for your notes, what is resonance? Okay, question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so for your summary, remember you can always write your own. Okay, so go ahead and pause this while you do your summary, and we'll see you next time.